Hello everyone. I am M. Venkatesh Reddy, working as Assistant Professor in the Department of Civil Engineering in the St. Peter's Engineering College, Hyderabad. Now I am going to explain about DRCS, in that particularly design of singly reinforced beam. So now first of all we can see where this exactly comes in the DRCS. So in that, yeah, these are the list of subjects which we are going to learn in the structural engineering in the Department of Civil Engineering. So these are the subjects we have to learn compulsory to learn about the structural engineering completely. So first one, engineering mechanics. So in this we have to learn about the forces, stresses, strains and so on. So all types of forces which are applied on the body, it may be rigid body or any type of body, we have to be learned. After that, strength of materials. So in the strength of materials we can find the strength of any material. Again, it may be the reinforced concrete material or the steel material. We have to be find its strength and its strains and so on the different parameters. After that, structural analysis. In the structural analysis we have to analyze a objective, a force, a deformation, a bending. All the things we have to be analyzed and we have to be said whether the structure is safe or not. After that, DRCS and DSS. So these two things are same. One is deals with the concrete and the other one deals with the steel. So in this entire world, any structure is to be constructed only the two materials. One is concrete structure and the second one is steel structure. So if we see whatever the today we are seeing the any structure, those are constructed either by the only two things. One is by the concrete structure. In the concrete also we can use the steel as a rods, as a bars, but second type of thing is completely a structure is constructed by the steel only, no need of any concrete. So first one, DRCS, which is constructed by the steel and concrete. Second one is completely by the steel structure. It may be slabs, it may be beam, or it may be any skeleton of the structure constructed by the steel. After that, PCS, so pre-stressed concrete structures. Before going to the structure, we have to construct the elements of the structure in a factory. So which is called pre-stressed. Before we are constructing whatever the elements we are constructed separately, we are taking away to the site and we are joining there. So which is called as pre-stressed concrete structures. We are applying the stress in the pre-zone. So there are the two types are there in the two parts of the thing. So pre-stressed, post-tensioned. After that, all these structures will be calculated for the finalizing of the total cost of the project in the estimation and costing subject. So these all are comes under the structural engineering subjects. So if you want to become a structural engineer, then you have to learn all this subject in one by one in the coming semesters in the Department of Civil Engineering. After this, so yeah, today my class is particularly focusing on the DRCS, design of reinforced concrete structures. So the whatever the structure under the DRCS which are constructed by the concrete and reinforcement, which means steel bars. So here we are. So in that, yeah, so now I'm going to explain about the DRCS. In some cases the DRCS is also called as RCC, reinforced cement concrete. So here, so the RCC in some people they may call, so reinforced cement concrete structures. So whatever the concrete we are manufacturing, we are going to create, which is created by the cement. There are different types of cement, there are different types of binding material. So those things we can use for making of concrete. So here particularly the concrete is made up of cement and we are using in the steel bars also, then we can call it as reinforced cement concrete. So the mainly we can call it as also called as DRCS. There are two technical terms in this. One is reinforcement and the second one is concrete. There are two technical terms. Again I am repeating, concrete and reinforcement. We have to mainly focus on the concrete and reinforcement. So the first material, so which is concrete, and the second one is about the reinforcement. Reinforcement are also called as reinforced. Yeah. So in the concrete is a mixture of four ingredients, mainly binding material. I can write and I can tell. So the concrete is a mixture of one, binding material. Second one, aggregates. We can call it as fine and coarse aggregates. And the third one, admixtures. And the fourth one is water. So the mixture of these four things we can call it as a concrete. So in that particularly, what is mean by binding material? A material which binds, which gives the bond strength between the aggregates, we can call it as binding material in generally. So the examples for these things are cement. So for the binding material in generally for the construction purpose we can consider as cement. In the worldwide the majorly manufacturing thing was cement. So cement, or also we can use the lime. There are so many examples for the binding material. Same as aggregates, here the aggregates are divided, or we can classify it into the two parts based on the sizes. One is fine aggregate and the second one is about coarse aggregate. Based on its size of the particle, we are classified the aggregates into the two types, fine and coarse. Fine, in the name itself we are saying that fine aggregate means smaller in size. In the coarse aggregate they are somehow bigger in size when compared to the fine aggregates. Admixtures also we have the two types or the two classification. So first one is about the mineral admixture. Second one is about the chemical admixtures. And the last one is about water. So for the binding material we are considering cement as a example. For the aggregates we are considering, and it is again classified into the two types, fine and coarse, based on its size. In the fine aggregates, the example for the fine aggregates is most of the places we can consider as sand, and for the coarse aggregate we can consider as gravel, which means also called as chips. So gravel and chips, their size in small in size sand, and gravel is larger. So for the binding material the example is cement. For the fine aggregate the example was sand. For the coarse aggregate the example was gravel. And for the admixtures we have the two types, mineral and chemical. Mainly the purpose of admixtures are to accelerate or retard the setting process. So the purpose of admixtures, either it may be mineral or the chemical or in any form. So the main purpose of these admixtures are, these are retarders and the accelerators. They can slow the process or they can fast up the process of the setting of the concrete. Yeah. So in the later classes we can go in depth about the admixtures. And water in generally we can consider as water, either it may be drinking water or the bore water. But the water whatever we have to use for the construction, it should be value more than 7. So the water we are going to use for the mixing of these things as in a concrete, which should be more than 7. pH value should be more than 7. Then we can simply we can use the water as in the concrete as a mixture. So for the concrete, these four, mixture of cement, mixture of sand, gravel and admixtures and water. So the mixture of these four things we can call it as concrete. After that, reinforcement in the next slide. Yeah, now reinforcement, what it means, generally the steel we can call it as reinforcement. So the steel are also called, in general terms we can call it as bars, which is made up of iron also. Yeah, so bars or the steel. So these steel, there are the different types of steel based on its yield strength. So as simple as that, concrete is a mixture of cement, sand, gravel, admixture and water. And as simple as that, reinforcement is a steel. So if you going back here, so concrete is one particle and the second one is reinforcement. So the concrete plus reinforcement is equal to, if in any structure if we use the concrete plus reinforcement, then we can call it is a RCC structure, reinforced cement concrete structure. So the structure has two main materials, which has the concrete and the reinforcement steel. Yeah, why we have to use a steel bar or the steel in the concrete? Because the subject name itself DRCS, which means DRCS are also called as RCC. Why for the concrete, for any construction in the concrete, with the concrete, why we are using the steel bars? Why it is linked with the steel bars? What is the main common factoria criteria in between these two? So the concrete and steel. So if we take concrete is a in nature, it is a brittle in nature like a glass type. So the steel is a ductile in nature. So both are exactly opposite in nature, but these two we are combining and we are adding, we are forming a structure which will be long last for the 100 to 150 years. It may be dam, it may be house, it may be road or anything. So one is concrete, one is steel. So why? Because so for the concrete, for the steel, only one factor is common, which is coefficient of thermal expansion. So the coefficient of thermal expansion for the concrete as well as steel is same. So in generally the coefficient of thermal expansion, so which is indicated by the alpha, and this coefficient of thermal expansion for concrete is same as coefficient of thermal expansion for steel, which the value is 1.2 into 10 to the power minus 5 per degree centigrade. So the expansion characteristic for the concrete and the steel which is same. So whatever the load which are applying on the structure itself, it means a combination of concrete and steel. A structure, if I say simply a structure, then you have to assume that it has concrete and steel. So the combination of concrete and steel is called a structure. So if any load is applied on the structure, so it will be expand same. So in the expansion characteristic in the concrete and expansion factor in the steel should be same. So how much of expansion it is going to be happening in the both cases should be same. So they both working as a one homogeneous material. So although in practically these two are different, but as a structure, as a one combined material, these two acting as a same. So which is the main reason we are using to steel as a reinforcement. We are combining the steel with the concrete in the RCS structures. After that, yeah, so the first majorly primer material in the concrete was the cement, which is very costly, and these are the more factors and properties. So in the cement we have the different types of cement based on the purpose, based on the strength, based on the grading. So first one, so we have the 33 grade, after that 43 grade, after that 53 grade. Based on the grades of cement we have these three types: 33, 43, 53. So based on the one factor, which was the specific surface area, so when the higher the number, the specific surface area is lower. So 33 grader has the higher specific surface area, is simply called as SSA, which has the more than the 53. So based on these three factors we can classify cement into these three grade. So based on the grade. So another factor for the classification was based on the purpose. Based on the purpose, so we have the different types of cement. First one OPC, ordinary Portland cement. Second one PPC, Portland pozzolanic cement. Third one low heat cement. Fourth one rapid hardening cement. Fifth one low weight cement. So like this we have the different types of cement. In generally the most common used type of cement is OPC and PPC, ordinary Portland cement and Portland pozzolanic cement. So this is about the cement. What about the another materials? Aggregates, admixture and water. So here aggregates. So in this we have the two types, fine aggregate and the second one is coarse aggregate. Fine aggregate we can call it as, we can take an as an example of sand, and for the coarse aggregate in general we can use the gravel. So the fine sand we can collect from the zone 2 area, zone 2 sand, and the gravel which have the minimum size of 20 mm. So whatever the chips we are going to use in the concrete which are use minimum size of 20 mm, and the sand we have to collect, we have to take from the zone 2 type. We have the different types of zones which we are collecting sand. So it is about the aggregates. After that, admixtures. In generally admixtures are the two types, mineral and chemical admixtures mainly, or also we can call it as retarders and the accelerators. Retarders which means slow in the setting time of the concrete, accelerator means which means fasten the setting time of the concrete. So after that, so the all these cement, aggregates, admixtures and water and the steel, these are the raw materials for the making of a structure and the concrete. So after that, so all these we have to learn in the BMCP, building materials and cement construction practice. So after that, again we are going to the structure. I can call it is a skeleton of structure. Like the human body we have the skeleton, and with the bones the human body, entire body will be the form like the skeleton, the structure will be constructed. So for the structure point of view, a skeleton will be called as a combination of footing, beam, column and slab. These four we can call it as a skeleton of a structure, which means I can draw and explain. For example, we can assume that it is a earth, it is a ground level. GL means which is called as ground level. So in the ground level we have to dig some soil where the loose soil has to be extracted and we to be stored in the some place where we can find the hard soil. Up to that point we have to digging of the soil, excavation of the soil. At this point we have to start our construction with the concrete. So first of all we have to construct one footing like this. This is called as footing. So the first foremost construction in the building, so which is called footing. After that we have to construct one PB, plinth beam. After that we have to construct the basement or the, so one layer. After that we have to construct the column which is a vertical member. It is called column. After column we have to construct one beam above the column, so which is called a beam. Along simultaneously with the beam we have to construct the slab also. Simultaneously with the beam we have to construct the slab also. It is called as slab. So the four major components in a building or in a structure we can call it as a skeleton, so which has the primary strength. So first one which is called as footing, the first and foremost part of the construction of building. After that plinth beam, after that column, after that beam. Along with the beam simultaneously we can construct the slab. Slab and beam both are constructed with the same time at a time. So these are the four or 4 to 5 major structural elements. We can call it as a skeleton of the structure. After that, so why we are going to learn this skeleton of the structure? So in the RCC, or also we can call it DRCS, so we have to design and we have to analyze one by one. So in this thing, first one beam, second one slabs, third one columns, fourth one, last one footings. So the design of these four components we can completely called as a DRCS, design of reinforced concrete elements in a building or in a structure, design of beams, design of slabs, same as columns and footing. So in that again, so the beams are two types. So first one, design of singly reinforced beam, so which is have the only reinforcement in the compression zone. So singly reinforced beams, doubly reinforced beams. In the slabs also we have the two types, one way slabs and the second one two way slabs. In the columns also again we have the two types, short column and the long column, LC and SC. In the footings also we have the so many types, but majorly we can practice and learn about the shape of the concrete, shape of the footing, which is called the circular footings, rectangular footings, square footings, and also mat footings and raft foundation. These also called as foundation. So raft foundation and the mat foundation. These are the different types of models or the problems, you can say anything, in the DRCS. Now I am going to discuss about the design of singly reinforced beam. It is called a singly reinforced beam, which means we are placing the reinforcement in the single direction, and it is a doubly reinforced beam in the two sides in the double, which means top and bottom we are going to place the reinforcement singly and doubly. So in the next slide, yeah, design of singly reinforced beam. DSRB, design of singly reinforced beam. So in this, for any design, for anything in the RCC, we have the methods of design. So before going into the design of any structural element, we have to know how many methods of designs. Yeah, we have the three types of methods of design based on the IS code book, Indian Standard Code Book. So we are going to use the IS 456 2000 code book. What it means, IS 456 and 2000? So IS means Indian Standard, and 456 is the serial number which will be given to this particular code book, and 2000 is the year which will be revision year. So actually this code book is invented in the 1987, but in the 2000 with some updation, with the updates, this code book is to be revised. So we can call it as IS 456 2000. So with the help of this code book we are going to design a beam. So again, back to the methods of design. First method, working stress method. Second method, ultimate stress method. And the third one which are using now, which is called as limit state method. First one. So the first two red ones are the outdated. Why these are outdated? Why we are not going to use in this design of singly reinforced beam in the practically, in the theoretically means? So in the working stress method, the factor of safety whatever we are going to use, which are very high, which means, so for the concrete I can say C, it which is for the concrete it is 3, and for the steel it is 1.5. So for the concrete the factor of safety in the working stress method is about 3. In the working stress method the factor of safety in the steel is 1.5. These are the very high values which are directly leads to the increasing in the cost of the total project. So which means in this method we are going to design, we are going to give additional strength, more strength, which going to be not used in the entire lifetime of the structure. So these are, in terms of financially point of view, these are very outdated. We are spending more money if we design anything in the working stress method. Same as ultimate stress method also. These two are about the stress governing methods. So which means stress governing methods. which means these two methods are to be designed based on the stress. When the stress is more, the structure thickness or the structure concrete quantity wise is more, which directly impacts on the financially. So the stress is more and the cost of the project is also increased. In the limit state method, this method is developed based on the strain. We have the two terms, stress and strain. This is going to be learned in the engineering mechanics itself. So strain. Yeah, so the working stress method, first one, ultimate stress method, second one. These two are to be developed based on the stress governing method. If the stress is increased on the structure and the structure thickness will be increased, the cost of the structure is also increased. But the limit state method, it is developed based on the strain governing method. So the what is mean by stress, what is mean by strain, in the next slide we are going to learn, but it is based on the strain governing method. So in this, so in the one point of view, we can simply say that why it is effective in terms of financially, in terms of practically, which means the factor of safety here we can call it as partial factor of safety. So the partial factor for the concrete is 1.5 and for the steel is 1.15. If we can observe whatever the values here mentioned, for the concrete it is 3, which means the higher the strength, higher the bigger the size, larger the strength and more cost also. Here half of the partial safety factor is to be reduced. Here 3, here 1.5, here 1.5, here 1.15 only. So in terms of cost, in terms of size of the structure is also small. Whatever the structure we need based on the working stress method, we can take it. Yeah, now coming to the limit state method. So the whatever the IS code we are discussed earlier here, IS code 456 2000, the code name was plain and reinforced concrete structures. The code name itself it is, which means the code of practice. So the IS code 456, the code book is designed based on the limit state method. There are some formulas or there are some concept of the working stress method and ultimate stress method in the code book, but the entire code book is mainly depends on the limit state method. So in this, again there are the two parts, limit state of collapse and limit state of serviceability. If I write here, limit state of collapse, second one limit state of serviceability. Yeah, so the first factor is about the limit state of collapse. In this we are going to address about these particular 5 things. First one, flexure, second one shear, third one torsion, compression and tension. These things if we have to address, then the limit state of collapse is to be completely designed. In the other hand, limit state of serviceability, in this after the construction whatever the defaults we can came on the structure, we have to be addressed here. First one, cracks, second one, deflections. When the load is applied on a structural element, it should be bent, some deflection will be formed, we have to be calculate that. Third one, for the any earthquake type of loads, for any high wind loads, the structure will be vibrated. So third one will be the vibrations. So these things we have to be addressed. Whatever the on the board, these three if we design, if we address, if we check, then the complete structure design is to be complete. So under the limit state method, we have to be design about the flexure, we have to be design shear, we have to be design torsion, we have to be design compression as well as tension. And after design, which means after finding of the values or the strength of these things, we have to be checking for the cracks, for the deflection, for the vibrations also. So So the design is not covered about the finding of these things, but also the checking of these factors also. Yeah. After that, again the same heading, design of singly reinforced beam. So what is mean by singly reinforced beam, what is mean by doubly reinforced beam? Singly and two, what is 1 and 2? If we take the stress strain diagram of a singly reinforced beam, so before going to the topic, so the how a body will react when the force is applied, there are two types of forces here. Forces, first one compression, second one tension. So the pulling towards is called tension, pushing towards is called compression. Or force applied towards a body, which means like this, applying towards, applying like this, we can call it as compression. Compression force we are applying from the top and bottom. Same body, if we apply the force, we can call it as like this. First one push, second one pull. So applying towards a body, applying away, it is called tension. So there are two types of forces in this entire world we can apply. From these two forces only, there are stresses will be developed within the body, there are strains will be developed, and there are bond stress, shear, torsion, all the things will be formed. So the first of all, if we applied a force towards, we can call it as compression, and away we can call it as tension. If we applied, for example, in this example, in the example 1, we can consider, if I applied a compression force of, it is indicated by the P or F, 10 kilonewtons. So the force will be calculated in the kilonewtons. So if I apply the 10 kilonewtons on the body of, it may be the concrete body or the rigid body or the steel body or any type of body. If I applied a force on the a body which is 10 kilonewtons, then it will be change its position like this. Yeah. So the original position of the body is this. After that, the if I applied any force, the deflected body shape was this. So some volumetric from shape changes will be there, same as here also. After applying the tension force, like for example 5 kilonewtons or any weight, it will be changes like this. Yeah. So these are the deformed shapes after applying the tension, after applying the compression of some weights. So here from these concepts we can develop the stress and strain. So before going to the design of the any structure, we have to know the some basics definition. What are the different types of forces? There are compression and tension, pulling and pushing towards and away. So we can call it as compression and tension. After that, if we applied any force on a body, the body internally or the externally or the extreme fibers, some stresses will be developed. So for example here, if I applied only tension or a compression at the extreme fiber or the top fiber, the stress will be developed internally. Of course the stress will be developed internally, but where it is exactly, at the neutral axis, at the top or bottom. So this is called neutral axis, we can generally NA. It is top extreme fibers, it is bottom extreme fibers. We have the different zones of the body. So where we can apply the force and where the which fibers are going to react, which are going to be formed the stress. So if we applied any type of stress, then if we applied any type of force, some stress will be developed in the body. What is mean by stress? It is indicated by the sigma. So the formula of the stress is, it is defined as load applied by cross section of the area or cross section of the area. So the ratio of load applied to the cross section of the area, we can call it as stress. After that, strain again, epsilon, change in length by original length, change in length by original length. What it is here, the change in length, it is the original length from here to here, which is indicated by the 2 meters for example, and it is deformed, it is compressed somehow inwards, so which is 1.5 meters. So how much of the change will be happening here? 0.25 which is 0.5. So 0.5 change in dimension by original dimension, which is the 2. So whatever the value we can get, which is called the strain, and the load by area. What is here the load? 10 kilonewtons by whatever the area of this block is to be, for example 2 meters and 3 meters L and B, 2 3 is a 6. So here if I take here 10 kilonewtons by area was 2 into 3. So whatever the value we can get, which is called as stress. So the units of the stress is Newton per mm square. For the strain we don't have any units, because it is dimension by dimension, both will be cancelled and there will be no units. Yeah, for the stress it is the units are Newton per mm square. For the strain, no units. So my main point was, if any load applied on any body, these things has to be observed. So it may be compression or tension. So the some stress will be developed, some strain will be developed. So likewise, these are the things. Not only the stresses and strain, we have to address about the flexure, which means bending, whatever the shear, this is called shear, and torsion, one side fixed and the another side rotational force is applied, which is called torsion, and the compression and the tension. You know the compression and tension. So these 5 things if we address, if we design, if we calculated, then it is called as limit state of collapse. Like that we have the limit state of serviceability, and we have to calculate the crack width or the crack length, and whatever the deflection it is going to be happen, and what are the vibration it has to be taken. If we address all these things, then only the complete design of structural should be finished. So yeah, again I'm writing design of singly reinforced beam. So we learn about the forces, we learn about the what are the things we are going to be addressed in the collapse in the second one. So here stress strain, block diagrams regarding to the singly reinforced beam, stress strain block diagram meters. So in that, so first of all, same concept again I'm explaining. Take a beam, because I'm going to explain with the singly reinforced beam. If I applied the compression force of load P equal to PC, particularly which is called compression, 10 kilonewtons, then if we divide the entire beam into the different parts, so the middle axis we can call it as neutral axis. There are no stresses or anything in the middle axis. It is called top fiber, and it is called the bottom most fiber, last fiber on the body. So there are the different fibers, how much we can divide, how much in there. So yeah, if I applied the compression force on the top of the body, so this body which can be divided into the 2 parts, topmost body and the bottommost body, part 1 and part 2. So the topmost zone of the body is experienced the compression portion, and the bottommost part of the body will experience the tension force. How? So the deformed shape of this body is, it will be look like this. So it is called compression, it is called tension. So the initial shape of the body is this, which will be looking like rectangle. This rectangle, after applying of the compression force on the top, it will be look like this. So the topmost or the top zone of the body will experience, or the top fibers of the body will experience compression force, and the below the neutral axis will experience the tension force. So it is called compression force fibers and the tension force fibers. For this reason, we are going to introduce a steel bars in the tension zone. Why? Because concrete is strong in compression zone. Here, what about the bottom? Concrete is weak in tension zone. here if I write where here. So concrete where it strongs and where it weaks. Based on this logic, we are going to introduce the steel. Concrete is strong and weak. If I write the two things, concrete is strong in compression zone and weak in tension zone. For this purpose, for compression zone, we no need to add any extra materials. It will be take care of itself. But in the tension zone, it will be very weak. The structure may collapse or failure. So for the not doing of the things in the tension zone, we are going to introduce the steel. Why only steel? Because the steel is strong in tension and weak in compression. Again, if I write same thing for the steel, it will be reverse. Strong zone is tension zone, weak zone is compression zone. So the concrete is strong in compression, steel is strong in tension. With this logic, we are going to introduce the steel bars in the tension zone. Again, if I draw here, or otherwise from here, it is a one rectangular beam. It is neutral axis. Here at the bottom, after applying of the load, it may be compression or tension. So the bottom part of the body will experience the tension force. For the tension, the concrete is weak, so we have to introduce the steel bars here. These are called as steel bars. We can mention it by the AST, area of the tension steel. So the top post is taken by the compression forces. It is tension forces. Okay. So now I'm going to draw the stress strain block diagrams for the singly reinforced beam. Again, I'm not explain about the why it is called singly or the two. So why singly? The concept was singly reinforced beams is the first concept, and the second one is doubly reinforced beams. There are two types of beams, singly and doubly. Why we can call it as singly? Because the steel reinforcement is to be introduced in the one part or the one zone of the beam, which means bottom. Why? Because the beam, after applying of the compression load, top portion or top fibers will experience the compression force, bottom fibers will experience the tension force. So for the tension portion, concrete is weak. Wherever the weak portions are there, if we introduce the strong material like steel, then the entire structure will be strong, which is the logic. So based on this thing, we can introduce the steel in the tension zone. Okay, so we are applying only steel bars at the bottom. So here if I write in the fill in the blank type of answers, where we can introduce at the bottom, at the bottom zone, or also called as at tension zone. So the steel fibers are to be placed at the bottom zone or the tension zone. We can call it is a singly reinforced beam. It is a beam, rectangular beam. So if we add same steel fibers at the top also, which means at the compression zone also, if we add, now it is called as here AST, here A suffix SC, area of compression steel, here area of tension steel. So if we apply the compression steel at the top here, at top and bottom, not only the top and bottom. So in the top and bottom, in the both zones, in the compression zone, in the tension zone, in the both zones, if we add the steel bars, then we can call it as double E, because we are applying the two times. We are placing the steel bars in the two portions where it is compression and tension zones, which is the majorly factor which can differentiate these two things. So at only bottom we can call it as singly, top and bottom we can call it as doubly. Okay, in this slide only I can explain. Yeah. So okay, I will take a new one. Again I draw the rectangular beam. So the middle part we can call it as neutral axis. Here it is called as NA. neutral axis. On the neutral axis there is no stress, there is no force, it is will be 0. So at the bottom portion we can add the steel reinforcement because beam is weak in AST. So the width is indicated by the small b, width of the rectangular beam, and the depth, or also we can call it as height, capital D, overall depth of the beam. And from here, from middle of tension reinforcement bars to the top of the beam, we can call it as small d, effective depth of the beam. There is a small difference. Capital D is about the overall depth of the beam, small d is about effective depth of the beam, small b is width of the beam. So there are the terms like small b, sorry, small b, small d, and capital D and neutral axis. We have to follow the terms in here. So it is called, and the top portion is about compression, bottom zone is about tension. If we applied the load, P is indicated P or F in some textbook, it is referred as a T. So after that, so we have to draw its stress block diagram and strain block diagram. First of all, stress, strain. So from the bottom, so the stress strain block diagrams are to be drawn in between the top of the beam to the midpoint of the tension bars. Once again I am repeating, in the small d zone only we have to be draw the stress and strain diagram. First of all, strain diagram. It will be look like two rectangles in the opposite direction. So as simple as that, two rectangles in the opposite direction, right angle triangles, as simple as that. It is called as a strain diagram, strain block diagram. Okay, then here, so the topmost strain or the maximum strain in the, it is called compression zone, it is called tension zone. So the maximum strain in the compression zone top fiber is 0.0035. How I can write this? 0.0035. Based on the IS 456 codebook, they already done intensive research and they given these diagrams. We should not do the starting step of the design. We can use the whatever the formulas from the IS codebook and we can do the our steps. So the maximum strain in the compression zone is 0.0035 for the singly reinforced beam. So the maximum strain in the tension zone is 0.002, which is called proof strain, plus 0.87 Fy by Es. What is Fy, what is Es? I can explain later. It is called the maximum strain in the tension side, maximum strain in the compression side of a singly reinforced beam. So it is strain block diagram. Likewise, stress block diagram. Here, one rectangular portion up to the off, from here to here, it is called parabola. Okay, up to here, for your reference I am making the marking. From here it is called rectangular portion, after that it is parabola. At the bottom there is no shape, then we can simply by putting the arrow we can write the value. So the maximum strain in the steel is 0.87 Fy. Maximum stress in the compression is 0.446 FCK. These are the maximum stresses, maximum strains in the stress and strain block diagrams. After this, so yeah, we can name it stress block diagram. Where these diagrams, where these values we can draw it from the IS codebook 456-2000. Once again, if we see, it is the stress strain diagram, stress block parameters and strain block parameters. Once again I am repeating, small b is the width of the beam, effective depth of the beam, overall depth of the beam. It is the top portion is, top zone is about compression. If you applied any load on the from the top, and the bottom zone is experiencing the tension force. After that, so because the tension is to be weak in the concrete, we are introducing the steel as a reinforcement bars. We can call it as AST, and here same like we can call it as ASC, area of compression steel. Here we have to assume one thing, so that bottom post or the bottom or the tension zone concrete strength was to be ignored, completely ignored. So the ignorance of the tension zone. After that, we have to draw the strain block diagram, stress block diagram. These values has to be taken from the directly IS 456 2000 code book. After that, so, and one more thing, if we want to mention here, from here to here I can call it as, it is a neutral axis. So the depth of neutral axis I can call it as XU max, X suffix U max, and this, so the total value from here to here is small d. So if we minus the XU max, then whatever the remaining portion will get, which means d minus XU max. So the top portion, which means the compression zone, is XU max, and the bottom is d minus XU max. What is mean by XU max? Actually we have the different types of sections: balanced, under, over. So with these three things we are going to design whatever the singly reinforced beam which will be comes under either balanced or under or the over reinforced section. So if we want to know the balanced or under or over, from which section it is to be categorized, first of all we have to know from how to calculate the structure is going to belong either balanced, over, or the under. So for this purpose we have to calculate two things. Yeah, first one, for the type of section we are going to calculate these two things: maximum depth of neutral axis, XU max, and the second one, actual depth of neutral axis, which is called as XU. So one is XU max and one is XU. So if the here type of section, types of section, our singly reinforced beam belongs to, first one, if the XU max value is equal to XU, then it is called as balanced section. And the second one is about, if the XU max value is greater than XU, then it is called under reinforced section. And the last one, if the XU max is less than XU, then it comes under the over reinforced section. So these are the three categories. Either our beam is going to comes under the either balanced or under or over. So yeah.